I've talked about how we can calculate the acceleration and velocity of an electron between parallel plates using the same method that we use when we calculate acceleration due to gravity, using the same acceleration equations. Now, there is another way to do such a problem, also relying on the similarities between the two uniform fields, and that is to use energy instead of the acceleration equation. Now, using energy is often easier if it is possible. So let's try that. Now, starting from the example with gravity again, when the ball drops, the potential energy of the ball gets converted to kinetic energy. So let's say if the starting height of the ball, the starting height is d, we know that the potential energy is given by m, the formula m, just call it PE, potential energy, and GH. Okay, and kinetic energy, which the ball will gain when it just before it hits the ground, is given by the formula mv squared. Now, the kinetic energy must be equal to just before it hits the ground must be equal to the potential energy when the ball was dropped. The reason is that when the ball falls to the ground, it loses potential energy since h drops to 0. So this decrease in energy, alright, this energy that has disappeared as the potential energy goes to 0, it cannot just disappear and be destroyed. So it must have been converted to kinetic energy instead. So therefore, those two must be equal. So let me write this down. So half mv squared must be equal to mgh. Now in this case, d is my height, so h is d. So this is equal to mg d. Okay. And so I can now solve for the v. If I notice that the mass can cancel, divide m from both sides, v squared equals to 2gd, and so v is the square root of 2gd. Square root of 2gd. So now let's move over to the case of the electron between the parallel plates. We can use the same idea. Except that we don't have the familiar formula mgh, which we normally use for gravitational field. So instead, what is more familiar in the case of electron is the work done. The work done is given by is related to the voltage So let's say the voltage between the two plates is V. Okay, and the distance, the distance in between is still equal to D. But the voltage in between is related to the work done when the charge moves from one plate to the other. It's related by the definition of voltage, which is work done over charge. In this case, charge is the charge of the electron, and this work done when the field moves the electron from top to bottom plate must have been converted to must give the kinetic energy of the electron when it reaches the other plate. So when the electron reaches here, it would have gained kinetic energy. So let me try and relate the two. If I rearrange this to get an expression for the work done, W would be equal to charge times velocity, and in this case charge is the electronic charge, so that would be E times V. And the kinetic energy here, kinetic energy is once again equal to half mv squared. Okay. Now since the work done by the voltage, by the electric field, gives the kinetic energy, therefore half mv squared here must be equal to EV. Let me write this out. Half mv squared is equal to EV. Now we should be a bit careful here because the V here is a capital V. It means the voltage, but the little v there is this velocity. So that's big V, that's little v. Now we can now solve for the little v, because if you remember, for this problem the voltage was 1.5 volt. It's the same exercise that I did in the last 1 or 2 videos. Okay, so I can now solve for the v squared and therefore the v. So let me start by moving everything to the other side. So 2 comes up here, 2EV, and m comes down here. And I will take the square root. So I know 1.5 is V, m is the mass of the electron, E is the charge of the electron. So we can substitute in the numbers, and if we do that, we would get the same answer as before. So let me just make sure I know what the numbers are. So V is 1.5 from there. E is the electronic charge, which is 1.6 times 10 to the power of minus 19 coulomb. V is 1.5 volts, and the mass m of the electron is 9.1 times 10 to the power of minus 31 kilogram. So we do know all of these numbers, and therefore if we put these numbers into our calculator, the answer we would find should be 726,000 meters per second. The same answer that I got in the last session by using the acceleration equation.